We're going to start graphing this function by looking at that denominator to find those vertical asymptotes. I have a habit of doing that first. So looking at the denominator and trying to figure out when x squared minus 9 equals 0. You have to be a little bit careful here. I always like to handle this with factoring because then I never miss any answers. So I would factor this into x plus 3, x minus 3, which would tell me that the vertical asymptotes happen when x equals -3 or +3. You can write that as x equals plus or minus 3, but you definitely need to have that x equals there. If you wanted to solve this by isolating, like adding 9 and square rooting, you can totally do that. Just keep in mind that when you put the square root in there, you have to include a plus or minus when the root is an even root. So I'm going to go over to where x is 3. I'm going to draw a vertical line. And I'll go to where x is -3 and draw another vertical line. These are the places that make the denominator 0, which is not allowed to happen. So that's where I'm going to draw the lines that I cannot cross. Moving on to the vertical asymptote, the horizontal asymptote, I like to look at these lead terms and simplify what's left. So in that case, we're going to have x over x squared, which is really 1 times x over x squared. And if I cross off an x, I'm left with 1 over x. And we have a situation where we have x left in the denominator after simplifying, which tells me that the HA will be at y equals 0, because the HA is for what happens when x gets large, and when x is large, 1 over x is very close to 0. So I'll draw on my borderline at y equals 0. That x-intercept is all about what makes the numerator 0. So if I can't solve it in my head, I can always write down x minus 2 equals 0 and solve this and find that 2 is the point. That'll be a point on the x-axis. It's an intercept. And then for the y-intercept, I'm going to look at these terms as if they were one number. So I'll take that -2 over -9, which of course is equal to 2/9. Now to graph this point, I don't have a calculator handy necessarily. I just need to figure out kind of where it is on the y-axis. It doesn't need to be exact. And since 9 will not go into 2, like 2 is smaller than 9, all I know is that it's positive, but it's less than 1. It's like a little bit more than 0. So I'm just going to put some point that's on the y-axis a little bit above the 0. And this is the situation I've got to deal with. I've got to try to graph. I've got 3 sections. I've got a section here, a section here, and a section here. The middle section is the easiest one to do because I have both of these clues. If my graph's going to hit both these points, follow like a natural kind of like trend line and also approach these asymptotes, then as I hit this green line, I'll have to curve down like this, and then here I'll have to curve up. Anytime our HA is on the x-axis, it gets a little bit confusing. So if you want to plug in like x equals 4 to the original problem and figure out where that is, we can do that. I'm going to do that actually. So we'll take x equal to 4 in the original problem. So if x is 4, I get a 4 minus a 2, and 4 squared minus 9, which is 2 over 16 minus 9, or 2 over 7. Again, that's kind of a weird number, but what I care about is that it's positive. So for x equals to 4, the graph will be up here somewhere. So I can draw something that looks like this. I could do a similar thing in this first section, maybe with x equal to -4. With x equal to -4, I get -4 minus 2, which is -6. -4 squared plus 9 becomes, or minus 9, becomes 16 minus 9. So we get -6 over 7. Don't care too much about the number. The fact that it's negative is all I really care about. If x is -4, the y value is negative. So I'll get this graph. But I will point out that as promised, all the problems in this class, if you look at a vertical asymptote, these graphs are like diagonal of each other. If you look at this vertical asymptote, these are diagonal of each other. So you can kind of just eyeball it and know it's going to have this shape if that trick makes sense to you. Good luck.